Hello, I'm here this morning to talk to you about your assignment for today. This assignment is called the Evidence for Evolution Google Slides activity. Now, your version might look a little different than the version that I'm going to actually be showing you, but it should be very, very close. So I'm going to give you some pointers along the way. So this is the document. I'm going to read through the background, and then I'll show you how you're going to fill in the respective slides. So it says Evidence for Evolution. Evolution is often called a theory. Many people in everyday use this word theory to mean a hunch or an idea. In science, however, the term theory is used differently. Scientists use the term theory to mean an explanation for some part of a natural world. A theory can be repeatedly tested using observations and experiments. As well, theories have extensive supporting evidence. Scientific theories have withstood testing and are a well accepted form of scientific knowledge. Scientific theories are broad and explain many other areas within science. Evolution is a unifying theory in the field of biology. There is significant evidence that supports the theory of evolution. So, with this being so, last week you went through the different pieces of evidence. So, this is going to kind of summarize everything that we've been talking about over the past couple days. So, let me make this a little bit smaller to fit. So, this next section right here, this is talking about anatomy. So if you look at this picture, which you'll use to answer a couple questions on the next slide, this talks about a frog, a cat, a whale, a lizard, a bird, a bat, and a human. And if you look carefully, those bone structures, they all have the same bones. They're shaped a little bit differently, but overall they have the same bones, even though all of those different organisms use those limbs, quote unquote, differently. Okay, one's used for grasping, one is used for swimming, one is used for walking, etc. Okay, so that's what you need to know for that second slide. So what you'll do on this one is it asks you what is the function of all of these four limbs, which are basically the lower part of your, like on humans, your radius, your ulna, your humerus, and then your carpals, metacarpals, and your phalanges. Okay, so what is the function of all of those foreign limbs? So you would tell me explicitly what that is and describe how the mammalian foreign limbs are similar. Okay, so why are some of them the same color? The next piece of evidence is dealing with embryos or embryology or embryological evidence. So if you look at, again, this is a visual. You can kind of see this is a human, a rabbit, a cat, a hog, a chick, a tortoise, a salamander, and a fish. So you can see them going vertically or like a column up and down. That's kind of how the embryos develop early in the mom. So if you look at that picture right here, you'll answer these questions. At which stage 1, 2, or 3 is most difficult to tell the embryos apart? Explain your reasoning. So stage 1 is the one up at the top, the middle is 2, and stage 3 is down at the bottom, and they're rows. So going across, which stage is most difficult to tell apart? And then the second question, which you might have more questions, but the second question, describe at least one similarity in the structure of these embryos. Okay, so what can you always pinpoint or what can you always find? The next one is dealing with fossil evidence. So you're going to put them from the simplest or the oldest to the most complex, which would be the most recent. So the youngest and the oldest. So the simplest is the oldest, and the more complex is the most recent. So you'll look here. Oops, let me make this a little smaller for you. Okay, so you'll drag and drop. Okay, and you could put them in the respective parts. Okay. Next, after reading below, use the reading below to answer the questions on the next page. If you look here, hint, this will help you with the first question. So molecular evidence is specifically usually talking about like DNA, or if they have how many amino acids in common, or the DNA commonalities. So sometimes you'll give a percentage or how many differences there are. The lower the number, the more closely related they are. So that can give you, if you read through this background here, that will help you with that. Sorry, I forwarded a little bit. So there's the respective questions. Well, my computer doesn't go crazy. Here we go. So there's a couple questions there for you to answer. And then the last couple slides deal with vestigial structures. Vestigial structures, as you know, are the old remnants of an ancestor that really have no current function or purpose in the modern counterpart. So if you look here, there's two respective questions. What do all vestigial structures shown have in common? And infer, what do you think vestigial means? And then the last question, which is a really important idea. It says, in general, all these types of evidence support the theory of evolution because they point to the existence of a what? Different ancestor or a common ancestor. So like I said, this is kind of a review of the evidence for evolution Google Slides activity that you're going to be doing today. If you have any questions, feel free to reach out. Again, don't be alarmed if this is a little bit different than the one that you're seeing. It's we had to edit and modify for a couple classes. So if you have any questions, please feel free to reach out to your teacher. We love to help. Have a great day.